Today we're going to solve some basic log equations, and this is not real challenging if you remember what we did with exponential functions, because remember that a log equation is basically an exponential equation switched around. So if I have log base 9 of 27 equals y. All we need to do is start with the switcheroo. Okay, we're going to start by rewriting this as an exponential equation. I call that the switcheroo. 9 to the y power equals 27. Go from 9 to y and then to 27. Now, we already know how to do this problem. Now it is just an exponential equation, which we need to write both sides with the same base. So I would write this side as 3 squared to the y, and I would write this side as 3 cubed. And we already have what we want, which is 3 to a base. Power to a power, you multiply these two. So that's actually going to be 3 to the 2y. So I can drop the 3's now, and I have 2y equals 3. Divide both sides by 2. Y equals 3/2. So it's basically just an exponential equation after you do the switch. And of course, there's those kind of strange situations where you have to deal with maybe a positive or a negative exponent, like this one, log to the 1/4 of 64 equals x. A lot of the same situations we dealt with before, where when I switch this one around, I'm going to have 1/4 to the x equals 64. Well, if I'm going to use the one-to-one property and drop those bases, I have to write them both, in this case, as a power of 4. So this becomes 4 to the -1 to the x. This would be 4 cubed. Once again, we have a power to a power. So this is -1x equals 3. Divide both sides by -1, x equals -3. Just trying to clue you in to a couple of the little tricks of the trade. This one might hang up some people. How about log base n of 8 equals 3/4? Well, when I do the switcheroo on this one, I get a little bit different situation. I have n to the 3/4 equals 8. Now you might be thinking, well, I thought we're supposed to write them both at the same base. Well, not always. In this case, it's going to be better if we raise it to a power that will get n by itself. So what we want to do is raise this side to a power. So, and that means I'm also going to have to raise this side to this power, whatever that is going to be, so that n is by itself. Now remember, a power to a power, you multiply. So don't I really want n to the first power? Right? I mean, we never write the 1, but we want n to the first power. So wouldn't it make sense if I raised this to the 4/3 power? Just the reciprocal power. And that means I'd also have to do the same thing over here. I'd have to raise that side to the 4/3 power. And look what I get. 3/4 times 4/3, those are inverses, those are multiplicative inverses, that's 1. So I get n by itself, and now I just need to do the cube root of 8 to the 4th. So the cube root of 8 is 2, and isn't it 16? So that's a little trick that you may have to use a little bit tonight. Let's just do one more and then we'll be done. log base 1/81th, I didn't know you could say that, but I did, equals 1/4. Log base 1/81th of y equals 1/4. Well, once again, our first step is always to do the switcheroo. So I switch these around and I have 1/81th to the 1/4 power equals y. Well, actually, y is by itself. I just need to figure out what the flip 1/81th to the 1/4 power is. Well, isn't it, if it's the 1/4 power, isn't it the 4th root of 1/81th? Right? And if you use your root sheet, I think 81 is a perfect 4th, right? So, the 4th root of 81 is 3, the 4th root of 1 is 1. My answer is 1/3. You just take the 4th root of that side. And we're going to stop there for today.